The Israeli PARRISE team of the Science Teaching Department at the Weizmann Institute of Science in Rehovot has collaborated with Gymnasia Herzliya High School in Tel Aviv to promote teachers' awareness of responsible research and innovation, RRI, through local and global socio-scientific inquiry-based learning, SSIBL. Students at the Gymnasia Herzliya High School have initiated several years ago a long-term project designed to explore the cyanobacteria Arthrospira, spirulina, as one solution to end world hunger, and based on ideas and solutions developed by the students themselves. Spirulina is a rich source of essential amino acids, carbohydrates, and trace minerals, and since it requires only sunlight, water, and trace metals such as magnesium to grow, it is an excellent source of nutrition where there is an undersupply of food. The challenge was to find conditions to accelerate the growth of spirulina in low-tech environments. The collaboration between the two institutes took the form of Teachers' Professional Development Course, TPD, in which the SSIBL was introduced to the teachers implicitly and explicitly, and took place on-site at the high school. During the first part of the TPD, the orientation phase, the teachers received a preliminary introduction to teaching socio-scientific issues in general and concentrating specifically on solutions to world hunger. Then they received an overview of the Spirulina project and attended relevant lectures on socio-ethical issues. These sessions were followed by discussion groups on teaching responsible citizenship within the educational system. The final part of the activity was Controversy Mapping Workshop as a means of organizing diverse perspectives in socio-scientific issues so that the connections between scientific, technological, social, ethical, political, and legal aspects can be discussed. The teachers were divided into groups and spontaneously raised social issues for analysis. They were asked to identify stakeholders involved in the interrelationships between them. They chose controversies related to vaccination, recycling, biogas, and more. The second day was the experimentation phase, in which the SSIBL was still implicit. The IBSE aspect, the science inquiry, was explicitly introduced. The PARRISE team led lab experiments specifically intended to explore the optimal conditions for the cyanobacteria Arthrospira, spirulina, growth. The inquiry activity included direct observations and discussions of ways to relate this method of learning to the school curriculum. The experiments were followed by group jigsaw knowledge-sharing activity and discussions of ways to translate the theory into practice and implementing such practices in classrooms. On the third day of the TPD, the conceptual phase, the teachers were introduced explicitly to the SSIBL framework, including the overarching context of RRI and the three pillars. The SSIBL approach was explained by a guest scientist from the Portuguese PARRISE team, Maria João Fonseca from ICETA UPS, and the teachers were then asked to prepare their own SSIBL projects for implementation, taking into account feasibility within the constraints of the school curriculum. On the fourth day, the reflection phase, the teachers presented their designed projects with subsequent reflection and discussion. The ideas and tools used by teachers' projects demonstrated their perception of the SSIBL and its components.